Hey guys, this is your teacher, of course, but today we're actually going to do this by recording. Now, I'm going to upload this to YouTube. I will send you the link. Probably you'll be watching that link right now. And if you do, go ahead and sign up for my channel, subscribe, and that way when I put something up, you'll know immediately. So we're going to do this today so you can get used to how we're going to do this for the rest of at least the next 2 weeks. Remember, I'm not going to be here at the end of this week and all of next week. So I want to see how this works. Alright, so get used to this. Again, the good thing about this is if you don't understand something I said, or if you don't understand the concept, write your notes down. That's fine the first time. By the second time, you should probably just put your pencil down and listen to see if you understand everything that's going on. Alright, so let's get started. Now this is actually called a definite integral. Now the only difference in what we have done here and what we have done in the past is one simple thing. When you have this integral, normally we had some function and we're integrating with respect to x. Alright, and when we do, what you're going to see is you're going to see a number here and another number here. So which I just say was a and b. Now what that actually means is that anytime you see this represents the area under the curve between A and B being x coordinates. Alright, so for example, if you have something like this, you really don't need calculus for this, but if you're doing something like this, if I ask you how far have you traveled in 1, 2, and 3 hours, if you're going at a constant rate of 40 miles per hour, well, you know that you would do after 1 hour, you would multiply 40 miles per hour times 1 hour, and that gives you 40 meters. Alright, after 2 hours, well, you would do exactly the same thing, 40 miles over hours. If you remember, this is very similar to what you did in hopefully your physics class. And you got times 2 hours. Well, hours would cancel and you end up with meters, which in this case would be 80 meters. And if you do that one more time, then you would get that the answer would be 120 meters, right? So what actually represents that on here, if you're looking at this, if we split this into 1, 2, and 3 hours, alright? Now the area under this curve, alright, between the x-axis and this curve, in this case is a straight line, well, this area right here, and if you look at it, that's just the area of a rectangle whose height is 40 and the base is 1, so 40 times 1, well, that's 40. Alright, so that actually gives you, the integral actually gives you, the area under the curve gives you this answer right here. So again, the area under the curve in this case represents distance traveled. So again, area under the curve represents distance traveled. Alright, and if you're looking at this, well, this would be in hours in this case, and velocity would be in miles per hour. Okay, now on the next thing, says what does this graph, the graph below describe? So all I can say, I'm not really sure what they're looking for here, but the area under the curve on this one and this one, alright, let's say that, let's put some numbers on here so this hopefully makes more sense. If this was 4 and that was 2, we're going to call this area 1, we're going to call this area 2. Okay, so again, we'll be looking for the area under the curve, or in this case, above the curve. So that area right there, okay? The area under the curve represents displacement. Now we're actually seeing this happening graphically, but if you remember, if we had a displacement function and we take the derivative of that, we get the velocity. So in this case, we're actually going backwards. Now, on this graph, that's represented by the area under those curves, all right? So to do this, first what we're actually going to do is we're going to take just simple geometric figures. In this case, we have two triangles. So, you know, the area of a triangle, hopefully you remember, is 1/2 base times height. All right, so let's say this F, we said that was 40. This is 2 hours, that's 4 hours. So if we want to find this area right here, we would have area is equal to 1/2 times 2 times 40, and that will give you 40 miles. All right. Now that would be for area 1. For area 2, we would have 1/2 times 2 times negative 40. Now you can call it negative 40, or you can see that this area would be negative because it's below the x-axis. Either way, this is going to give us negative 40 miles. Okay. Now the total displacement is area 1 plus area 2. In this case, notice that they're the same number but opposite signs. So the displacement, again, that's going to represent displacement. Is going to be 0. Alright, so total displacement would be 0. Now, to find the total distance, all we would have to do is add this area, basically the absolute value of that area and this area. So that would be 40 plus 40. So the distance traveled is actually 80 miles. Okay, so make sure that you know the difference between total distance. Total distance represents how far I've gone. Not displacement basically means where I started and where I ended up, and I basically add those two. And in this case, the total displacement was 0. The total distance was 80 miles. All right, now let's go to the back to something that we're going to see quite a bit on the homework and from now on. All right, basically I already talked about this. Remember, this is called a definite integral because you have a certain range that you're going to go between A and B. All right, so to do one like this, all right, the first thing we're going to do on here is just kind of simplify this. We're going to try to do this without our calculator. So this would be between -2 and 1. We're going to find the integral between -2 and 1 of 1/3 x plus 2/3 dx. Now remember, I have not taken the integral here. All I've done is simplify this. So I basically split it up into two different fractions so I can graph this. All right. If you look at this, this is the equation of a line. The y-intercept is 2/3, and I'm going to go up 1 over 3, which would be that point. All right. Now I've already put those points there. So let's see. Now there is going to be some estimation that's going to happen here. So if you have a line that's not exactly like mine, you should get around the same answer. All right. Again, we're going to do this without a calculator. If we had a calculator, then, or if we knew how to do it any other way, then we wouldn't need a calculator. So, all right. So the first thing we're going to do, basically, all we're trying to find, okay, we're going to try to find the area between -2 and 1. So -2 is right here, and 1 is right here. So basically what I'm trying to find first is this area right here. This area that I just colored purple. Okay, so we're going to say and I'm going to write this for your notes, but if you're listening to this, you don't have to write it. You can estimate by finding the area under the line. Okay, so all we have, if you look at it, this is just a triangle with a base of 3 and a height of 1. So in this case, it would be area is equal to 1/2 times 3 times 1, which in this case is 1.5. All right, so this is the answer for this one. That's it. There's nothing else to it. As easy as that. Okay, so as you can see, you've actually been sort of integrating for a long time. You just never knew it. All right, on the next one. Now, on the next one, we're actually going to try to find the area between 0 and 4 under the same curve, right? So this and this is the same line. So, let's see, between 0 and 4. Now, 0, it's right here. Okay, so there's going to be some overlap here. And 4 is, let's see, 1, 2, 3, 4. 4 is right here. So we're going to try to find the area. And this is going to get a little messy because you know, I don't have a limited amount of paper to waste, but if you look at it, this would be the shape of a trapezoid, all right? And we're going to call this base 1 or 2, and we're going to call this base 1 or 2 here, and the height would be 1, 2, 3, 4. Okay, so if you don't understand, that's okay. The area of a trapezoid area of a trapezoid is equal to A is equal to 1/2, area is equal to 1/2 base 1 plus base 2 times the height. Okay, so now in this case, I'm going to turn this quickly just like this so you can see what I'm talking about. The base is going to be this one right here. You notice that the base is 2, and the other base, since we're starting at 0, we're going to call this 2/3. All right, so we're going to call this 2/3 right here. So we have the area right here is going to be, sorry, the base is going to be 2/3 here. The base is going to be 2, and the height is going to be 4. Okay, so that's what I'm going to write on here. So area is equal to 1/2 times 2/3 plus 2 times 4. Now that's going to give us 16/3. Okay, so that is that. Now finally, on this last one is the same type of example. It's just we're integrating over a different range, if you will. So on this one, they want us to go from -5 to 4. So if we're going to go between -5 and 4, I don't know, let me use a green pen here. -5 would be, let's see, 1, 2, 3, 4, 5. So we want to integrate between this -5 all the way to 4. Let's see, where's 4? 1, 2, 3, 4. Okay, so 4 is right here. Now, if you look at this a little bit easier, because all I have, and I could probably shade this green, but I don't want to make this too messy. This is a triangle right here, and you have another triangle there. So actually, we're just going to find the area of those two triangles. Notice that the green one, the one that I have highlighted green here, that one's going to be a negative area. Okay, so let's we're going to split this up into two different ones. We have between -5 and -2. Again, I chose that because that's going to be easier for me. This is -5 and that's -2 right here, and that's going to give me this little triangle of the same exact, it's over the same curve or line in this case. We're going to add that. Now we're going to go between -2 and +4, which is right here. Okay, so we have between -2 and +4. And that way we can just do two triangles. That'll be quick. Okay. Okay, so this one's going to be equal to 1/2 times 3 times -1. Now remember, I just put -1 because the height would be -1 right here. Okay, plus 1/2. Now this other triangle is this triangle from here all the way to here, right? So notice that the base is 1, 2, 3, 4, 5, 6. And the height is going to be 1, 2. Okay, so the base is going to be 2 on this one. So the final answer on this one is just going to be -1.5 plus 6. Okay, and that's going to be equal to 4.5. Alright, so as you can see, it's pretty simple. I'm going to be in class today, so if you got any questions, make sure and ask me, but this shouldn't be extremely hard for you. Alright, I guess we'll talk to you tomorrow.